We will be solving a trigonometry proof, and we will start with sine theta over sine theta minus cosine theta equals 1 over 1 minus cotangent theta. Okay, so the first thing we're gonna do is we're gonna ignore this side and we're gonna work with this side to change cotangent in terms of cosine and sine. So you will end up having 1 minus cosine theta over sine theta, which will equal to 1 over 1 minus cosine theta over sine theta. Let's remember, we have to be able to subtract, we have to have the same denominators. And to do this, we're gonna multiply sine theta minus cosine theta over sine theta. And then you will end up having 1 on the top. Having 1 on the top and sine minus cosine theta over sine theta, you will end up doing 1 over 1 sine theta minus cosine theta over sine theta. And keep in mind that when you do this, you will have A over B, C over D. You will always multiply these two and this two, which will equal to AD over BC. Okay, so you will do that with this part, which you with sine theta over sine theta minus cosine theta. And as you can see, this equals to this, so it's actually right. For this problem, we will be solving a trigonometry equation. So we're going to be using 3 cotangent theta minus the square root of 3 equals 0. So the first step you're going to do is move everything to the other side and leave theta alone. So you're going to add the square root of 3 to both sides, which you will end up having 3 cotangent theta equals square root of 3, and then you're going to divide 3, and you're going to leave cotangent theta over square root of 3 over 3. You have to change cotangent. You have to find the reciprocal for cotangent, which will be tangent theta. And whenever you do the reciprocal for this one, you have to do the reciprocal for this, the other side too, which will be 3 over the square root of 3. So remember that you have to leave theta alone. To do that, you're going to move tangent to the other side, and you will be left with theta equals tangent to the power of negative 1 times 3 square root of 3. Okay, after you've done this process, you're gonna try to look for the degrees. For this step, to be able to find theta, you're gonna go to mode and change your radians to degrees and press enter on degrees, and you click second mode to quit. After you've done that process, you're gonna plug in tangent to the power of negative 1 times 3 over the square root of 3. So you will do the second power to 10, and you're gonna plug in 3 divided by over the square root of 3, and remember, close parentheses. So you will get the degrees of 60. So your degrees will be 60. Okay, let's remember that after you got in the degrees of tangent, well, remember that you only have one answer for that one, which will equal to, if you refer back to the unit circle, you will see that in 60 degrees you have pi over 3, but that's only one answer. So we're missing the second answer for this problem. To find the other answer, we're gonna use a unit circle. Okay, we have found the degrees for the problems, which was 60 degrees, and which equal to pi over 3. And let's remember that for this one, to find this answer, we have to find the reciprocal, which was tangent, if you remember. And in the unit circle, tangent stands in this quadrant. So the opposite of 60 degrees will be 240 degrees, which will lead us to 4 pi over 3. So the other answer for problem 3, cotangent theta minus the square root of 3 equals 0. The first answer will be the degrees, which is 60 degrees. Second answer will be pi over 3. And third answer, we will end up having 4 pi over 3. And that's how you find the degrees and the two radians for this problem. Okay, the first thing you're gonna do, you will have to find the period, which will be pi divided by b, which is pi over 3. And for the increment will be where you will have to divide period divided by 4, which is pi over 12. Now you have to find where your graph will start, which will be 3x plus pi equals to 0, because you have parentheses equal to 0, which you will end up having x equals pi over 3, which of course equal. So we want the denominator in of the start to be the same as the increment, which you will change it to negative 4 pi, due to the fact that this was negative pi over 12. The middle point will be negative 1, and from that, and now you have to find the high points and the low points, which the amplitude is 2. So we start at negative 1, so the high points will go up, so it will be y equals 1, and from negative 1 it will go 2 down, which will equal to negative 3. So that will be your low point. Now the pattern for this one will be a is greater than 0, which will be middle point to high point, asymptote to lower point to middle point. So that will be your pattern. Okay, after you've known the period, the start, the increment, the middle and high and low points, and after you know the pattern for the problem, we're gonna graph it. So we're gonna start at the start point, which is negative 4, 12. Start in the middle, which is negative 1. So negative 1 and negative 4, pi and 12 will be here. So let's remember, we start with middle, then we go high, which the increment is by 12. So we skip 1, which is the one right here in the middle. Gonna go to the next increment, which is this one, going to be on 1. After you come to the high point, you're gonna go to the asymptote, which is this line. this is your asymptote. So you mark your asymptote as always, your vertical asymptote in other words, and then you go low. So your low is 3. Then again you go to middle, which is 1, high, which is 1, right here in the middle of this two. Like, let's remember that there's an increment between the 2 pi over 12 and the 0, so that will be a high, and then your asymptote again, and then low, you go low again, which is 3, middle, 1, and then again high, which is the next increment on 1, and then again your asymptote, which is all the way over here. Okay, to go to the other side or work the opposite way, you're gonna go to low, which is 3, and then asymptote again, and you go for a high, which is 1, middle, low, asymptote again, and then you go, and then you continue doing that. Now I'll leave it right there. So at this point we're gonna connect the points, so it will be this side like that, and then this one like that. That way. Infinity. Although this ones don't look as the others due to a small space. And that's kind of how the tangent graph will look like in graphing for tangent equations. We'll be solving trig proofs, and it's fairly easy. So for our example that we're going to use now, it's tan squared theta plus tan to the 4th power theta equals secant to the 4th power theta minus secant squared theta. So basically we have to be proving that this will equal this. So for that, we're just going to focus on the first part. So what we have to look for now is that tan squared theta is inside tan to the 4th power theta, so we're going to bring that out. We're going to factor it. So it's going to be tan squared theta, and we're going to use a 1 to hold the place. 1 plus tan squared theta. That's it. So now to get secant, we have to think of tan. We're going to have to convert it to secant. We're going to have to solve it in terms of secant. For that, we're going to have to look at our Pythagorean identities. And if we look at that, it's 1 plus tangent squared theta equals secant squared theta. So we're going to write that secant squared theta times tan squared theta. Now, what we're going to do is we have to turn this tangent into secant also. For that, we see that tangent squared theta equals secant squared theta minus 1, and then it's times secant squared theta. So now what we have to do is distribute this secant squared theta to both sides, and we multiply
multiply secant squared theta times secant squared theta, you get secant squared, to the fourth power theta times negative 1, and then that means minus secant squared theta. And as you can see, we have proven that this is equal to this. To solve a trig equation, first let's back up a little. We're gonna have to go to remember algebra a little bit. So whenever you were in algebra, you would get an equation similar to this: 4x minus 3 equals 0. To solve for x, first you were supposed to move the 3 to the other side, so that would make it positive. You were left with 4x equals 3. Now, to isolate x, you have to divide by 4. So you're left with x equals 3 over 4. Well, keep this method in mind because it's really similar to solving a trig equation. You use the same method. So the equation that we're going to be using today is 2 sine squared theta minus 1 equals 0. So first we're going to have to move the minus 1 to the other side, and we're left with 2 sine squared theta equals 1. Now we're left with this 2 here, so we're going to divide everything by 2, and that turns into sine squared theta equals 1 over 2. So now you see that we also have a squared, so we need to get rid of that squared. So for that, we're going to have to square root sine squared theta and the 1/2. We're going to have to square root both of them. So now we're left with sine theta equals, here whenever you square root 1, it's going to be the same thing, it's 1, so you don't really need the square root up there. So you're just going to be left with 1 over square root of 2. But you can't really have a square root in the denominator, so we need to get rid of that square root in the denominator. We're going to have to move it, so we're going to use that denominator to multiply it by itself. We're going to multiply the numerator and the denominator by the square root of 2. Once we do that, 1 times the square root of 2 is going to equal the square root of 2. Square root of 2 times square root of 2 is going to be the same thing, square root of 2. So now we still have the square root of 2 in the denominator, so we're going to multiply it again by the denominator. So it's going to be square root of 2 times square root of 2. And now we can actually move it. We can move the square root of 2 to the numerator. I'm going to end up with square root of 2 at the numerator and a 2 at the denominator. Now we found that theta equals square root of 2 over 2. And if we look at our unit circle, we're going to find that square root of 2 over 2 in terms of sine is the y-intercept, so we're going to find that it's this one right here, so it's pi over 4. If you keep looking at it, it also is 3 pi over 4, this other side. And then since it's a square root, it also can be positive or negative, and you can also find that it's 5 pi over 4. So to graph a tangent function, first we must understand what the parent function is. And to start with that, we will be using y equals tan x. So first of all, to graph this, we will set it up like usual, the graph. But the asymptote is going to be different than with the other graphs because this one is set as pi over 2 and negative pi over 2. So this is where we will be drawing our asymptotes. And our graph is going to look somewhat like this. But we have to remember that for our period, when we have to figure out our period, to figure out our period we have to use pi over b, meaning b is the number that's going to be in front of the x. So in this case it would be 1. So it's just going to stay like that. Pi over 1 is going to be pi. And that's the period for the parent function. But that will change as you change the equation. So now we will be changing the equation and we will graph y equals tan x over 2. In this case, the only thing that has changed is the phase shift. So to graph that, first we must solve for the period, which is pi over b. And in this case, the number in front of the x is 1. So it's pi over 1, but then the 1 is also being divided by 2, so it will be pi over 1/2. And then we have to multiply it by the reciprocal so that we can simplify it. So it will be 2 over 1, 2 over 1. So then we get 2 pi. That's gonna be our period. So now we're gonna have to set it up like that. Pi, and then pi, and we're gonna get 3 pi, and then negative 3 pi. Those are gonna be our asymptotes, and it's gonna be the distance that in between each asymptote. That's what the 2 pi means. That's going to be the distance between each asymptote. So for x, whenever you solve for x, you're going to get 0. So there's no change in there. So all that it's going to be is the graph is going to be is. Oh my God, it's so bad. Do not do that. The graph is going to be going through the center upwards, remembering that there's phase shift and just like that. So yeah, that's what it is.